All right, class. So we're going to get started with this assignment here. I'm just going to give you a brief overview of how to do this. We're just going to read through the instructions together. I'll do the first example for both parts. I do need you to do both parts today. I will not have you, first of all, worry about this information down here today. We will talk about that more in class. What I want you to do here is to practice. So, first of all, always put your name on things, because if I can't find your stuff, I can't give you a grade for it. Also, real quick side note, I know that you guys are going to be given this in paper form. You do not have to do this on some kind of PDF editor. I just want you to use the paper that we gave you, and then I'm using my iPad here so that I can actually get this all recorded down. So we're going to start with the first of all, making sure that you are on the right assignment. Always double check that there. We are going to start by going to tinyurl.com and the balancing sim. So, keyboard, tinyurl.com slash balancing sim. If you don't go to this right here, make sure that you reread through your URL. Make sure that I would double check to make sure that this S is capitalized. Sometimes that they're really touchy about that kind of stuff. But make sure you're in the right spot. You're going to click on the introduction section and make sure right here, I can't show you on my iPad, but you're going to make sure that the tools here are selected as none, just like the direction says. So school is just reading directions. If you read the directions, you'll actually do pretty well. So you're going to complete these 4 questions over here. And we're going to start with this first one. So make sure, like I said, you're in the introduction. And for this first one, your directions are for the quote, make ammonia section, sketch the particles and write the balanced equation. Make sure that everything is balanced, 90% of what we're doing today. And write the balanced chemical reaction equation in this box here. So we're going to make sure that this setting here, right here, is on the make ammonia section. So this is the one that I'm going to do with you, and you're going to use these same concepts. And each time that you move to a new box, make sure that you switch to the box that it needs you to. So for this next one, you'll switch to the separate water there. See how everything changes. All right, so sketch the particles and write the balanced chemical equation. So what do we have here? Well, we have these dials that we can change that will add different chemicals. Now, the big thing that you will need to notice is the different numbers and the different colors of these atoms. The different colors will represent a different atom in the whole molecule. So on this right side, we have NH3s. So there's that one blue for every time that there is just one molecule. There's one blue, which is the N, the nitrogen, and 3 whites, so 3 hydrogens. And that is bonding together in one molecule. Then on the left side, we have dinitrogen or nitrogen gas, which has the two nitrogen atoms in the one molecule, and then we have a H2 gas, which is just 2 hydrogens bonded together. And what this whole process represents is the rearrangement of the atoms in this reaction. So this arrow in the middle is showing that a reaction is happening. So you are still, the goal is to have it so that you have the same number of atoms of each kind on both sides, because just like our conservation of mass concept, you are not going to lose any of those atoms. They don't just disappear or come into existence out of nothing. They are always going to be there, just in different rearrangements. So this left side is going to transform its makeup, its structure, into the right side, and those numbers of atoms are always going to be there. So we have to make sure that this is balanced. So on this right side, we can only have, every time we add a new molecule, every time we grab a new package of items, you always have a ratio of 1 nitrogen to 3 hydrogens. So if I add another full molecule, I now have 2 nitrogens and 6 hydrogens, excuse me. So same goes for 2 nitrogens and 2 hydrogens. So we need to find a way to balance this situation. So if I start with one N2 molecule, the lowest number of nitrogens that I could possibly have is 2 nitrogens. So before we even worry about the hydrogens, we need to move over to this next side over here, where it has 1 nitrogen. So if we know we need 2 nitrogens and each package of NH3 has just 1 nitrogen in it, we need to have at least 2 nitrogens in there. And so therefore we need 2 full molecules of NH3. But that will change the other side, this left side, about how many hydrogens it has. So we now have, like I said, we need to always do, not always, but it's super helpful to have a running tally right here of what you have on the left side and the right side of your equation here. So on the left side, we have nitrogen and hydrogen. So on the left side, we have 2 nitrogen. Now we added 2 of those NH3s, so now we have 2 nitrogens. But on the left side, we don't have any hydrogens, but on the right side, we have 6, because there's 3 for each of the molecules, so 3 times 2 is 6. So how do we get 6 hydrogens on the left side? Well, that means that we just add sets of 2, because this comes in sets of 2 right here. That's the package deal that we have. So we just need to add 2, 4, and 6. And see, this happy face will come up when you know that you have a balance. And part of why we're doing this assignment here is so that you can play with it, and it gives you live feedback right away. And it lets you know exactly when you're done. But I would really appreciate it. I think it's going to be very helpful for you to keep practicing with this box here. And and another thing that at least when you're doing it by hand that's super helpful is to just draw out the equation so that you can add. We'll worry about that another time. So either way, your goal is to get the particles, sketch the particles, and write the balanced chemical reaction equation. So we now know what the balanced chemical reaction that we have is. So that is a 1 nitrogen gas plus 3 H2s react to form the reactants go through a reaction to form the products, which is 2NH3 products. So that is our balanced chemical equation. So now we need to draw what you see there. So I have a handy little color change function here. So I'll just do it where I have 2 connected nitrogens. Try and make sure that you have those super clear so that I know that there's 2 different atoms in the 1 molecule. And then I'll be really specific here so I can help show things. And then for white, we'll just do circles. All right, does that equal what we have? So we have 3 times 2 is 6 hydrogens, and we have 1, 2, 3, 4, 5, 6. Perfect. So that side is balanced. And that will react to form 2 molecules of NH3. And I don't really want you to worry about the configuration. I'm more worried about the number here. So right here we have 1, 2, 3 hydrogens all connected to that nitrogen. So I want to make sure that you don't have to they have it in a very specific format on the left side. That's chemical structure that we're not going to worry about right now. All I want you to worry about with the drawing is making sure that you have the right number of atoms, the right number of molecules, and that they are clearly connected in packages. Just like this is all connected really easy and really well. An example of what I would not want is just like 6 there, and then we have 1, 2. Do not do that. This is what we want. All right. So that is your answer. That is going to be what gets you the check mark for my grading on this section. So move forward with the rest of this area. So go ahead and pause this recording to finish that out, and then we'll move on to the next section. Good luck. I believe in you. I really do. All right. Welcome back. I'm glad that you guys worked really hard on that first section. Now we're going to move to the game. So step 1, click on the game option on the bottom of the simulation. Step 2, remember game is at the bottom here. Step 2, click on the timer icon, which is over here on the left. I hope that that is helping. So that click on the timer icon so that it is on. Click the sound icon so that it is off. All right. Step 3, start at the level 1 option and complete the table below. Essentially, you are doing the exact same thing as you did on the other side, but this is all about a game. This is all about just practicing and making it fun. Remember, if you are able to get all of them right, to get through all of these 5 challenges, you will get a nice reward on tomorrow's class. So let's start with the first one. All right, and that is, I clicked on, let's go back because start over. So I clicked on the level 1, the green dot with the single 1 hydrogen. Okay, challenge 1 of 5, see that timer is going. I'm not really worried about what your time is, but I want it there so that you actually know, like it gives you a little bit of urgency, so that it makes it more of a challenge. Okay, and always try and get the best time that you can. So your reactants, let's see what we have here. So for this, the balance on, let's look at this on this side here. So what you could do here is essentially treat this line here as your arrow, and that's going to be your equation moving down forward. And then you can just sketch that on the right side. So for challenge 1 out of 5, so we have C2H2 as one package, and H2 as another package, and then the C2H6 as another package. So the goal is to get everything balanced, like I said. So what I would do is I would start with just checking out to see what we already have. So let's do left and right, carbon, and hydrogen. Okay, so on the left, we have 2 carbons. Come on, function. Okay, we have 2 carbons. We have 1, 2, 3, 4 hydrogens on the left side. 4 hydrogens. So if you remember that the little 2 is how, where'd that go? Little 2 is how many of this, whatever number, whatever letter it's under is how many of that element there is. So this equals 2 hydrogens. Okay. Okay, on the right side, we have 2 carbons. So that is balanced. That is balanced. We don't have to worry about making sure that we add things, but we do need to worry about whatever we add to this equation that stays balanced. So that's why it's important to start with this chart when you are beginning the balancing scenario. Sure, what else? Let's go with that. When you start balancing things, just start with the chart and then end with the chart. Make sure that you have everything that you need. So how many hydrogens do we have on the right side? Well, that 6 means that we have 6 there. So that's what we are working with. We need to add somehow 2 more hydrogens, and a really great way to start with this is, let's add through that stuff. So that's what we're working with. And there's the first one. So we need to just add 2 more hydrogens, and we have this handy H2. So if we just do that right there, and then we check it, balance. Got it right. Perfect. So just as a side note, another part of the reason why I'm not having you time yourself is because you're going to have to draw these. So I don't want you to waste, be under pressure to draw, I want you to draw it well, not necessarily draw it and rush through it. So we got that done. I would just make sure that you get that drawing at the end. So let's start with, we don't need this anymore because we checked it. And so let's draw the equation. We have 1 C2H2 plus 2 H22. And that reacts to form products, which is 1 C2H6, and that is balanced. So quick side note about this 1 here. You don't necessarily have to worry about adding the 1s because it's just it's understood that when you have this, for example, this right here, this is the same thing. The 1 is just helpful for right now as we're getting practice into how to do this. So I will totally accept this or this right now. All right. And let's go to drawing. All right. I'm glad that for this right here, we can definitely still see it. All right. So we have, like I said, I'm not super worried about the color scheme here. Let's just do circles for hydrogen and dots for carbon. They're usually black anyways, I think. Okay, so we have hydrogen, carbon, carbon, hydrogen, plus, let's do hydrogen, hydrogen, and hydrogen, hydrogen. Say hydrogen 1,000 times fast, it's going to be ridiculous, and it'll just be words. And then that reacts to form. See, that's a great example of a very complicated shape that we will not worry about in this course right now. So for this right here, I am totally fine with your carbon, hydrogen, 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 just doing the Lewis structure. And carbon, hydrogen, hydrogen, hydrogen. Okay. And that right there is what I need you guys to do. So please finish through the rest of the assignment here. Remember, you do not have to worry about this part here. If you want to give it a shot, feel free, but it'll be super helpful for you, but you are not required to. So good luck on the assignment. I believe in you guys. Have a good rest of your night.